Your feet press against the ground. The floor feels solid. The walls around you seem unmoving. Nothing suggests motion. Nothing suggests instability. Your body registers balance, support, certainty. You feel anchored, but that feeling is misleading. At this exact moment, you are moving through space at thousands of miles per hour. The planet beneath you is spinning. It is orbiting the sun. The entire solar system is moving through the galaxy. And more strangely than all of that, you are falling, not metaphorically, not philosophically, physically. You are falling right now. That sounds impossible because falling implies loss of support. It implies downward motion toward impact. When you drop a glass, it falls toward the floor. When you stumble, you fall toward the ground. Falling has direction. It has an ending. But what if falling does not require impact? What if falling simply means accelerating under gravity? Pause for a second and think about what you are standing on. The Earth is a massive sphere pulling everything toward its center. That pull never stops. It does not switch off when you feel balanced. It does not weaken because you are comfortable. Gravity is acting on you constantly. So why don't you feel like you're plunging? Because everything around you is falling with you. The ground beneath your feet pushes upward, preventing you from accelerating freely toward Earth's center. That upward push creates the sensation you call weight. It feels like support. It feels like stability. But what you are really experiencing is resistance to falling. Remove that resistance and the sensation changes instantly. Think about the brief moment at the top of a roller coaster just before it drops. There is a flicker of weightlessness, a lightness in your stomach. For a split second, your body senses the beginning of free fall. Now imagine that sensation extended indefinitely. No ground pushing back, no surface stopping your descent. That state has a name, free fall. And free fall does not always look like collapse. Sometimes it looks like stability. Sometimes it feels like standing still. Your senses evolved to detect changes in motion, not constant motion shared by everything around you. If the air, the buildings, the oceans, and your own body accelerate together, you experience calm. Relative to your surroundings, you appear motionless. But relative to the mass of the earth, you are being pulled inward every second. The unsettling truth is this: stillness is not the absence of motion. It is motion you cannot detect. And once you accept that, a deeper question emerges. If you are falling right now, what exactly does falling mean? When most people hear the word falling, they imagine a simple scene. A glass slips from a table. A person trips on a step. An object moves downward until it strikes something solid. Falling in ordinary language means dropping toward the ground and eventually hitting it. But physics does not define falling that way. In physics, falling means accelerating under the influence of gravity. It does not require downward motion in the way you picture it. It does not require impact. It does not even require a surface waiting below. Falling simply means that gravity is the only force acting on you, and you are allowed to respond to it freely. That distinction changes everything. When you stand on the ground, gravity pulls you toward the center of the earth. At the same time, the ground pushes up against your feet. That upward push prevents you from accelerating downward. You feel weight because the surface is resisting your fall. Remove the ground, and the situation transforms instantly. Imagine stepping off a high platform. The moment your feet leave the surface, there is no longer any force pushing upward against you. Gravity becomes the only significant force acting on your body. You accelerate downward. That state where nothing resists gravity is called free fall. Here is the part that unsettles intuition. In free fall, you feel weightless. Weight is not the force of gravity itself. Weight is the sensation of being prevented from falling. Astronauts orbiting the Earth feel weightless not because gravity has vanished, but because they are in continuous free fall around the planet. There is no surface pushing against them. They and their spacecraft accelerate together under gravity. Stop for a moment and reconsider that. The absence of weight does not mean the absence of gravity. It means the absence of resistance. Now bring that back to your current situation. You are not in free fall toward the Earth's center because the ground blocks your motion. The surface pushes up, canceling your downward acceleration. That push is what you interpret as stability. But what about other directions? The Earth itself is not resting in space. It is being pulled by the sun's gravity constantly. There is no cosmic floor beneath it, preventing that inward pull. Nothing pushes the Earth outward to cancel the sun's influence. Instead, the planet accelerates toward the sun every second. This is where the definition of falling expands beyond everyday intuition. Falling does not have to be straight down. It simply requires gravitational acceleration. If an object moves sideways while gravity pulls it inward, the path becomes curved. The object still accelerates toward the source of gravity, but its forward motion prevents direct collision. That is how orbit works. Picture throwing a ball horizontally. Gravity pulls it downward as it moves forward. The faster you throw it, the farther it travels before striking the ground. If you could throw it fast enough, the ground would curve away beneath it at the same rate it falls. It would keep missing the surface. It would be falling continuously. This means falling is not defined by crashing. It is defined by acceleration under gravity. Impact is optional. Now think about your body again. Gravity pulls you toward the Earth. The Earth pulls toward the Sun. The Sun pulls toward the center of the galaxy. At every scale, gravitational acceleration shapes motion. Whether you collide with something depends not only on gravity, but on how fast you move sideways relative to that pull. The unsettling implication is this: falling is not an accident. It is the natural response to gravity when nothing interferes. And if falling simply means responding to gravitational acceleration, then the Earth is falling. The Moon is falling. Satellites are falling. Even light bends and follows curved paths near massive objects, which raises a sharper realization. If the planet beneath you is falling through space and you are carried along with it, then your sense of standing still may be masking a much larger descent. If falling simply means accelerating under gravity, then we have to apply that definition honestly. The Earth is pulled by the Sun's gravity every second. That pull never stops. It never weakens into nothing. There is no invisible platform holding the Earth up, no cosmic support beam keeping it suspended. So by the physical definition, the Earth is falling, but it never crashes into the Sun. This is where intuition struggles. We imagine falling as a straight drop toward a central point. Yet the Earth's path is not a straight line inward. It is a curved loop, repeating year after year. That curve is not evidence that gravity has been canceled. It is evidence that gravity is constantly reshaping motion. To understand this, picture something simple but powerful. Imagine standing on a perfectly smooth Earth with no air resistance. You fire a cannonball straight forward. Gravity pulls it downward, and it eventually hits the ground. Fire it harder, and it travels farther before landing. Each time, gravity acts exactly the same way. The only difference is forward speed. Now imagine increasing the speed dramatically. The Earth is round. That means its surface curves away from a straight line. If the cannonball moves fast enough as it falls toward the ground curves away beneath it at the same rate. The ball keeps falling, but it never reaches the surface. It goes around the planet. It is falling sideways. That is not a metaphor. That is orbital motion. The cannonball does not escape gravity. It does not balance gravity. It obeys gravity completely. Its forward motion simply converts what would have been a downward plunge into a continuous curve. Now, replace the cannonball with the Earth. The Sun's gravity pulls the Earth inward relentlessly. At the same time, the Earth moves sideways at roughly 67,000 miles per hour. That sideways motion is not opposing gravity. It is what transforms inward acceleration into a curved path. The Earth is perpetually falling toward the Sun, but its forward speed ensures it always misses. Stop and sit with that. Every second of every day, the Earth accelerates inward. There is no pause, no neutral state. The planet beneath you is constantly curving toward the Sun. The reason it does not collide is not because gravity weakens. It is because motion redirects the fall. This also explains something profound about astronauts in orbit. When a spacecraft circles the Earth, it is not floating above gravity. It is falling around the planet. The spacecraft and everything inside it accelerate together because there is no surface pushing back. The occupants experience weightlessness. Weightlessness is not the absence of gravity. It is continuous falling. And this applies on every scale. The Moon is falling toward the Earth. The Earth is falling toward the Sun. The Sun itself is moving within the galaxy's gravitational field. At every level, motion and gravity intertwine. According to Einstein, gravity is not even a force in the traditional sense. Massive objects curve space-time itself. The Earth moves along the curved geometry created by the Sun's mass. It is not being dragged by a tether. It is following the shape of space. This makes orbit even more elegant. The Earth is not resisting gravity. It is not fighting collapse. It is following the straightest possible path within a curved space-time. What looks like circular motion is actually straight-line motion in a curved geometry. That means falling is not an error. It is the natural consequence of existing in a universe shaped by mass. Now return to your own experience. The ground beneath your feet feels solid because it pushes back against Earth's gravity. But there is no surface pushing back against the sun's pull on the Earth. The entire planet accelerates together. Everything on it shares that motion. You do not feel the inward fall toward the sun because nothing around you resists it. You and the planet are falling together, and the fall never ends. If the Earth's forward speed was slightly slower, it would spiral inward and eventually collide with the sun. Slightly faster, and it would drift outward into space. Orbit exists because of precise motion within curved geometry. So the next time you imagine the Earth calmly circling the sun, picture something different. Picture a planet in constant descent, curving endlessly through space, always falling, always missing, and realize that you are part of that motion. If the Earth is falling and you are carried along with it, the obvious question becomes unavoidable. Why don't you feel it? If you are in motion at tens of thousands of miles per hour, curving through space in continuous freefall, why does it feel like you are standing still in a quiet room? The answer lies in something your senses are not designed to detect: shared acceleration. Your body does not directly feel motion, it feels changes in motion. If you are inside a smooth airplane flying at a constant speed, you can stand up, walk down the aisle, and pour a drink without difficulty. You do not feel the hundreds of miles per hour beneath you because everything around you shares that motion. The air inside the cabin moves with the plane, the seats, the walls, your body, all traveling together. Relative to your immediate environment, you appear stationary. The same principle applies on a planetary scale. The Earth's orbit around the sun involves constant acceleration inward. But you, the oceans, the atmosphere, and the continents all accelerate together. There is no external frame of reference pressing against you to reveal that motion. Nothing pushes sideways against your body to signal that you are curving through space. Now consider freefall again. If you step off a ledge, you feel weightless during the drop, not because gravity has disappeared, but because nothing is pushing back against you. The ground normally prevents you from accelerating freely toward Earth's center. During a fall, that resistance vanishes. In orbit, something similar happens on a larger scale. The Earth falls toward the sun, and everything on Earth falls with it. There is no cosmic surface blocking that inward motion. There is no force pushing you outward to counter it. So you feel nothing unusual. Stop for a moment and rethink what weight actually is. Weight is not gravity itself. Weight is the pressure of a surface, preventing you from following gravity's path. When you stand, the floor pushes up. That push creates the sensation of heaviness. When you jump, there is a brief instant where nothing pushes back, and you feel lighter. In continuous freefall, weight disappears. Astronauts orbiting Earth experience this constantly. Their spacecraft and their bodies accelerate together under gravity. With no surface pushing back, they float. The same gravitational force that keeps the moon in orbit is acting on them fully. The difference is resistance. On Earth's surface, gravity pulls you inward, but the ground interrupts the fall. Around the sun, nothing interrupts the Earth's fall. You are carried along without sensing the curvature. Einstein described gravity as the bending of space-time. Massive objects curve the geometry around them, and other objects move along those curves. You are not being dragged by a rope toward the sun. You are following a curved path in space-time along with your planet. Because that curvature is consistent and shared, it feels like stillness. Your senses evolve to navigate local environments, uneven terrain, sudden drops, changing speeds. They are not equipped to detect smooth, continuous acceleration shared by everything nearby. So your experience of stability is limited. You are falling, but you cannot tell because nothing around you resists that fall. The ground feels solid because it stops one direction of acceleration toward Earth's center, but nothing stops the larger acceleration toward the sun. That motion is smooth, uninterrupted, and universal across your environment. And this reveals something subtle but profound. Stillness is not the absence of motion. It is motion without contrast. You do not feel the Earth's fall because you are embedded within it. Which leads to the final shift in perspective. If falling can feel indistinguishable from standing still, then perhaps stability itself is something far more dynamic than you have ever imagined. By now, the idea should feel less shocking and more precise. You are falling right now, not in a dramatic sense of losing control, not in a cinematic sense of plummeting toward disaster. You are falling in the quiet, mathematical sense, accelerating within a gravitational field while moving sideways fast enough to keep missing the destination. The Earth beneath you is in continuous freefall around the sun. You are in continuous freefall with the Earth. The reason you feel stable is not because motion has stopped. It is because the motion is shared. Stability, then, is not stillness. It is coordinated acceleration. When every object in your environment follows the same curved path through space-time, there is no internal signal that anything unusual is happening. The oceans fall with the planet, the atmosphere falls with the planet, your body falls with the planet. Nothing pushes sideways against you to reveal the curve. Nothing resists the motion to create tension, so your senses interpret the experience as calm. But beneath that calm is relentless motion. The Earth travels around the sun at extraordinary speed. The sun moves within the galaxy drifts within an expanding universe. At every scale, motion is constant, falling is constant, curvature is constant, and yet none of this produces chaos. It produces rhythm. Seasons repeat, days cycle, the sun rises and sets. The predictability you rely on emerges from motion that never stops. The Earth does not maintain its orbit by standing firm. It maintains it by falling perfectly. That is the quiet elegance of gravity. Once you understand this, the word falling changes meaning. It no longer implies instability or failure. It describes participation in the geometry of the universe. To fall is to follow the curve carved by mass and energy. To orbit is to fall without collision. You are not standing on a fixed platform in space. You are riding a trajectory shaped by gravity, carried by a planet in continuous descent that never ends. And the strangest part is this: it has been happening your entire life. You just never realized it.